Good evening, everyone. Okay, how are you guys? Fine. Now let us start with another video today. We are working on work energy theorem. As we all know, I hope this topic you have learned it so far. Let us start with one more video. I'm going to solve a problem which is a bit different from what you have done, what you have been doing so far. Okay. Now here, work energy theorem as applied to a particle's path. Let me just go back to my previous videos and tell you what difference does it make this problem, how different is this problem. So in the fourth video, MWE4, we had applied particles speed. The velocity was proportional to the displacement. That's what we had done. And as a result of it, I had asked you to find out what is the, the work done by the particle. This is what we had asked you. In the next video, what I did was, I said I'm going to use the same method, method, but the question is, instead of the speed being proportional to square root of displacement, because when it becomes proportional to square root of displacement, then we observe that the acceleration will be a constant. So in this case, I don't want the acceleration to be a constant. I changed this. Okay. So the difference between 5 and 4 is that in fourth video, you had the acceleration to be a constant. In the fifth video, acceleration is not going to be a constant. Okay. So therefore, one of these methods cannot be employed. That's what I was able to show. Now let us move on to the next one. Now what is given here? Now the displacement as a function of time is given to you. Okay. And you need to find out the work done. Now how do we do it? Okay. So now let us start with this. So it says the value of S is given to you. Value of S is given to you. And we know work done. I will write it down separately. Work done is equal to F dot ds. F dot ds. Okay. Where F is the force acting on the particle. See, do I get a force anywhere here? Nowhere. Okay, then how do I start working on this? This becomes a headache. Now, this particular problem, I don't expect any 9th and 10th graders to do it. It will be only for those who have learned calculus. Okay. So towards it, now I have S equal to so much. S is equal to, let me write it down. S is equal to T cube minus T square minus T plus 1. This is what I have. Now let me differentiate this. Okay. You have learned differentiation. So ds by dt. What is ds by dt? Velocity. This is displacement, right? ds by dt is velocity, which you will get this as 3t square minus 2t minus 1. This should be a velocity. Now I also need acceleration. Okay, what do I need for acceleration? So I've got the velocity here. So dv by dt, which means I'm going to differentiate it once again. Okay, this is a, which should now be equal to 3 2s are 6, 6t minus 2. This is your dv by dt. Okay. Now I first do by the first direct method. Okay, then I'll go for work energy theorem. Usually in all my videos you have seen, the second method is always the work energy theorem method. Okay, I'll continue with the same trend. So now, as a result of it, the first method, can I apply kinematics? I cannot. Reason is because you see, the acceleration is proportional to time. As long as acceleration is not a constant, you cannot apply equations of motion. So, equations of motion method cannot be applied. Now, we'll do from scratch. What is the scratch method? Scratch method is nothing but work done is equal to integral of f dot ds. F dot ds. Okay. Now, when I say f dot ds, what is this limit over here? See, in the previous exercise also we used the same thing. But here, unfortunately, what is this integral limit? We do not know. Okay, let us keep it aside. We'll write it later on. Now, here it is ds. At least now from this expression, we get to know what is the value of f. So I'll write down the value of f is nothing but mass times acceleration. Mass is 1 kg. So therefore, m times a is nothing but a itself, which should now be equal to 60 minus 2. See, force is dependent on time. Okay, that means as time changes, the force changes. See, if I put t equal to 0, force was negative. If I put t equal to 1, 6 into 1 is 6 minus 2 is 4. Okay, it is increasing. So force is not going to be a constant. So equations of motion are not applied. Now we are going to use this one. Now we have S is equal to so much, and we have ds by dt is given by this value. What I will do is here I'll write this as ds is equal to 3t square minus 2t minus 1 into dt. Can I write like this? Definitely I can do it, right? So I will take this value, plug in here, put in this value here. Okay, so my work done expression will read to be equal to, what is f here? 60 minus 2, 60 minus 2 multiplied by this value. What is this value? 3t square minus 2t minus 1 into dt. This is what it is. So now let us apply the limit. See, everything is in terms of t. So I can easily apply t equal to 0 seconds to t equal to 2 seconds. 0 seconds to 2 seconds. Okay. Now let us find out what is the value here. See, here 2 is common. I'll remove 2 here. And I will write this as integral of 0 to 2 of 3t minus 1 into 3t square minus 2t minus 1 into dt. Okay. Now let us expand this. So how do we expand? So let us write it down. 2 into integral of, something wrong. 2 into integral of 0 to 2 of, let me expand this. This will be 3 into 3 is 9t cube, 9t cube. 3t minus 2, 3t into minus 2t should be minus 6t square, minus 6t square. Then 3t into minus 1 is minus 3t, minus 3t. And then minus 1 into minus 3t square, it will be minus 3t square. Minus 1 into minus 2t should be plus 2t plus 2t. Minus 1 into minus 1 should be plus 1. Plus 1. Right? And then you have a dt common. Okay, I'm not going to multiply by all of them. I'll just keep it outside dt here. Now, as a result of this, now you see this is 90. Okay, let me write it down. Let me write it down here to get it correctly. So work done now will now be equal to 2 times integral of 0 to 2. And then there's no other t cube term here. I'll just write this as 9t cube, 9t cube. And then you have minus 6t square here, minus 3t square. It should be again minus 9t square. I have added these two terms, this term and this term. And then you have minus 3t plus 2t. This should be minus t, minus t. And then you have a plus 1 here. I'll retain plus 1 here. Then common to it, you have a dt here. Okay. Then you should write this as 2 into integral of. Now let me integrate this. When you integrate, what do you get here? 9 into t power 4 by 4, right? X power n plus 1 by n plus 1. I have used this formula. Minus 9 t cube by 3 minus t square by 2, t square by 2 plus t, and the limits is 0 to 2. Okay. Now what do I have here? This is 3 1s are 3 3s are. Okay, let me apply the limits directly. Okay, then we will do it. 2 into 9 by 4, 9 by 4 into t power 4. What is t power 4? 16, 0 minus 0 minus 9 by 3. I'll just write directly 3 here. 3 1s are 3 3s are. Okay, so this should be 3 into t cube. T cube should be 8 minus 0. Right? I applied the upper limit minus lower limit minus half into t square. What is t square? 4 minus 0. Okay, upper limit t square, 2 square minus 0 square plus 2 minus 0. Okay, I have done all this. Now what do we have here? This should be 2 into 4 1s are 4 4s are 9 4s are 36. Right? 36 minus 3 into 8, 24 minus 2 1s are 2 2s are minus 2 plus 2. I get this. So this goes away. So 36 minus 24 equal to how much? 6 minus 4, 12, 12, 12, 12 into 2, which should now be equal to 24 joules. So the work done by the particle to start from in a time interval of 0 seconds to 2 seconds is seen to be 24 joules. Very simple. But you know, so much calculations you need to. If this is only for a 2 mark and you are going to use something like 10 minutes to get this, there's no point in doing this, right? You can just exclude this work. Now, this method is a very lengthier method, but I just taught you about how to apply physics to using this method. Now let us look at the second method and see whether the second method is quite easier or not. Okay. What does the second method do? Second method tells me, right? Okay. Second method, M2. Second method is nothing but your work energy method. Now what does it tell you? It tells you the work done is nothing but half M into V final square minus V initial square. Okay. Now M is 1. So I'll just write half into what is V final. How do I know V final? V final is not given, but V is given, right? See here, V is given by 3t square minus 2t minus 1. We derived this. Okay. So from here, what you need to do is get the value of ds by dt, which is V, which should now be written as 3t square minus 2t minus 1. This is what is known to us now. Now, what do we need to do? V final. What is V final? Put t equal to 2 seconds, right? So V of 2, because it's a function here, right? V of 2 is equal to 3 into 2 square. 2 square is what? 4. 4 into 3 is 12 minus 2 into 2. I put this value. 2 into 2 is 4 minus 1, which should now be equal to how much? 12 minus 4 minus 1 is 7. Then you put V of 0. V of 0. Okay. V of 0 seconds. Okay. Because that is your initial. So this should be equal to, what is this now? 0, 0, minus 1. Minus 1. Okay. Now let us substitute these values. This value I'll substitute here, 49. This value, minus 1 whole square is plus 1. So it will be minus 1 over here. Why minus 1? Because it's minus Vi square, right? I have squared this Vi square. Vi square is nothing but initial velocity square. Okay. So this should now be equal to 48 divided by 2, which is 1 second, 24 joules. Wow. See, within 1 minute, I got the answer. Okay. This will take you 10 minutes. So which is easier? Work energy method is always easier. Okay. So you should learn it properly. But as of now, I have not given you any complicated problems. Okay. Let us do still further complicated problems in the next few lectures, in the next few videos. So until that, thank you friends for watching this video. Like, share, and subscribe to my channel to get more updates about the videos that I pour in across. And I would like to know more about the comments and what kind of problems would you like me to solve it. So you can post it or you can send it to my email ID. And by the way, I now have a brand website which has been in my name. I've been waiting for this domain for a very longer time. And what happened to this? Okay, multiple lines. My website URL is just my name itself. I don't know, somehow for the past 2-3 years I have been waiting for this name. Okay, somebody had already taken it, or maybe the domain was parked, was not able to get this. Now I got this name. Okay, it is ratankar.com. So you can visit my website, and if you have any suggestions for the modification, you can let me know, and we'll take it forward. Thank you, friends. Thank you very much.